Okay, we're in section 24, and the point of this is that we're trying to get you comfortable using software. And certainly the Sage is the application that we're promoting. And the number one reason is it's a free CAS system that's widely used. And although hard to use, you probably should start using some software to think about how software relates to the problems we're giving you. So I'm defining a function over here. I typed it in. I want to speed it up a little bit for you. And I'm hoping as you're reading the notes and you're going to class and you're thinking about things that you're doing this on your own. All right. Your engagement in this subject area will pay off if you continue moving forward. And that is thinking about what we're presenting to you using software to try to get a better understanding of it. So I define a function, f of x equals sine x over x. This is something you've covered in math 121 when you did the limit. You use squeeze theorem for that. And then I defined another function, g of x, which is actually this sum over here. All right, let me go through that. It's sum minus 1 to the n times x to the 2n divided by the factorial of 2n plus 1 for n. And I said 0 to 10. And then what I want to do is I want to plot both f and g between minus 20 and 20, y min minus 2, y max is 2. Let me do that. And what's going to happen, it opens up a graph of that. Now, clearly, I do see the blue curve and the green curve. And by the way, when I get in this region over here, the green curve is sitting on top of the blue curve. There is no difference. And what is that? Between like, minus 9 and 9, there appears to be no difference between that series and the graph of sine x over x. All right. Now, someone's going to say, could I improve this? And I want to point out by improving it, what you're going to do is I'm going to go back to the definition of g of x. And I got to do that for you. And I'm going to do, instead of 10, I'm going to do 100. All right. And then what I'm going to do is I'm going to do the plot again. Now, when I do this plot, another plot will open up. And what do I notice about this over here? This is the new plot. You cannot tell the difference between the blue and green curve. Both are being graphed, by the way. Over here you can. So as I did more and more terms, a better and better and better fit. All right. Thank you. Oh, before I do that, I just want to make sure you know that when you go through notes, there's other problems for you to look at where you can attempt to do this if you like, right? Many problems. There's many graphs being provided to you. The point of this is that you might think to yourself, does the fit always get better as you go out? Well, it will get better, but maybe not for all real numbers, maybe just for a band of real numbers, all right? So again, you may want to consider going back over what we've learned in class and trying it on your own. And again, we give you plenty of examples. Sometimes I'm using Grapher, sometimes I might be using Sage, whatever. Have some tools at your disposal. And the more time and effort you put into this, the more clear things will become to you. But again, there's homework problems to work through. Again, feel free to use software on that. But my intent is you really got to do things by hand without being able to have some kind of ability to do things by hand, that the computer's probably not going to be much benefit to you. But there will be some Sage code in the problems. And there's going to be some Grapher example. And maybe I'll do Wolfram Alpha sometimes. But, in each section of the notes, you're going to see eventually, after you get through all the material, and it does require a lot of work, you're going to see some Sage code over there. You may want to take a look at it, or including how to get a Taylor series using Sage. All right. Thanks for listening.